Hello, good evening, everyone. Welcome to the premiere of the movie called What is Ivermectin? I really like this movie. It's a short film, but it's quite powerful. It's kind of an inspiring and intellectually stimulating tracing of the history of ivermectin and its impacts on a number of countries as well as diseases in the world. And I got to tell you, that history is still being written, and this movie will bring us up to that point. And I find it, again, a very powerful movie. So I hope you enjoy it. I also want to thank Sean Burke and Adrian Urso for making this movie happen. Adrian's the director. I also want to thank our supporters for funding the movie, and also stick around after the movie because Adrian is going to do an interview and talk about how he got sort of inspired and involved in the project. And then also keep in mind, please follow and like us on this channel. Go to flccc.net to visit and follow us there. And then also, if you like the movie, please share on your social media channels. So again, thanks for joining us, and I hope you enjoy the movie.
What is ivermectin? Here are a few key points before we take a closer look. It was first discovered in 1973 and has been approved for human use since 1987, with more than 4 billion doses distributed worldwide. The World Health Organization has also included it on its list of essential medicines. And it's been called a wonder drug due to its versatility, safety profile, and beneficial impact it has had worldwide, earning a Nobel Prize to the two men who discovered and developed it. It's fascinating to note that ivermectin shares a very interesting trait with penicillin and aspirin in the fact that they were all found and derived from nature. But to truly understand ivermectin and its impact, we'll take it back to the very beginning. The full story of ivermectin begins with Satoshi Omura in the early 70s. Working as a microbiologist at the distinguished Kitasato Institute, he was searching for new antibacterial compounds. Having grown up in a farming family, he developed a deep respect for nature and believed, as he still does today, that it held all the things we need to have healthy and productive lives. Because of this, the Kitasato Institute was the perfect home for his research, having been founded by Shibasaburo Kitasato, who also believed in the discovery of drugs and vaccines derived from natural sources. That belief drove Professor Omura's purpose to discover useful chemicals and bioactive agents in nature, and more specifically in soil-dwelling organisms. He's collected thousands of soil samples from all over Japan to find and isolate these new microorganisms. One sample proved to be very promising. From soil that was taken very close to the Kawana Golf Club just a few hours south of Tokyo, Professor Omura and his team were able to isolate a new organism. Through a process of culturing and fermenting the organism, they soon found that it produced a very active class of compounds called ivermectins. All the right pieces were in place, as it was also during this time that Professor Omura and the Kitasato Institute had a partnership with the Merck, Sharp, and Dome Company, and all the resources they had in taking the compounds to the next level. It was 1975, and William Campbell was the head of an interdisciplinary team at the labs when they received the samples from the Kitasato Institute. It was his task to screen the sample along with 53 others sent by Professor Omura's team. The ivermectin was highly effective against worms and other parasites. They then modified it to be safer and more effective. That result was ivermectin. They have since searched the world over for the microorganisms that produced those original ivermectins. Quite remarkably, that sample site south of Tokyo remains the only place they've ever been found. An astounding fact considering the global impact the drug has had. In the time after isolating and screening the new ivermectins, further analysis revealed the efficacy against a diverse range of parasitic worms and insects. In fact, they found it to be 25 times more potent than other antiparasitic drugs. It was also the first drug in a new class that could treat parasites both internally and externally, called endectocides. In 1981, ivermectin was released commercially to treat animals and quickly became the top-selling veterinary drug in the world, used in both domestic animals and livestock. It was so effective, it nearly eradicated a roundworm commonly found in horses. But the goal was always a drug that could treat both animals and humans, so the work didn't end there. William Campbell pushed forward on more studies to see if ivermectin could be used against onchocerciasis, also known as river blindness, after finding that a close relative to the worm that caused river blindness was very effectively killed in horses. River blindness is caused by Onchocerca volvulus, a parasitic worm that can live in the body for up to 14 years. It's spread through the bite of infected black flies that carry the tiny worms in larval form from person to person. Aside from blindness, they also cause severe skin issues and intense itching, as well as being generally debilitating. In fact, in the West African savanna, half the males over 40 years of age were blind due to onchocerciasis. In 1981, Merck began clinical trials in Senegal. Safety was a top priority, so they began with a very small dose of ivermectin. River blindness was a massive health emergency, as well as a socioeconomic issue, and they were set on addressing it effectively with ivermectin. They found that a single annual dose would reduce those immature worms to zero. Ivermectin could then be taken annually for the life of the adult worm and prevent all the devastating effects of infection, including the blindness that was disabling so many. In 1987, Merck registered ivermectin for human use under the brand name of Mectizan. What followed was a great nod to George Merck's philosophy on medicine.
Merck and Company is an industrial firm, but in the conduct of our business, we have endeavored to live up to certain principles. We try to remember that medicine is for the patient. We try never to forget that medicine is for the people. It is not only for the profit.
They established the Mectizan donation program and began distributing ivermectin at no cost for the treatment of onchocerciasis, committed to continue their distribution for as long as needed and wherever needed. Ivermectin has proven equally effective in another devastating parasitic disease known as elephantiasis. To date, over 30 years later, more than 4 billion treatments have been donated in 49 countries for combined treatment against river blindness and elephantiasis. A component to the large ongoing distribution is the safety profile of ivermectin. In fact, the WHO concluded that ivermectin was so safe that with some training, non-medical people could oversee their community's ongoing administering of the drug. In 2015, Professor Satoshi Omura and William Campbell received a proper acknowledgement for their discovery of ivermectins and the impact ivermectin has had all over the world. They were awarded the Nobel Prize in Physiology or Medicine.
In the spaces of physiology or medicine, the ultimate goal is to achieve scientific breakthroughs that change our view of human health, disease, and normal vital processes.
From more than 40,000 different Streptomyces cultures, he was able to identify a completely unknown type, Streptomyces ivermectilis. That contained a compound never seen before and which would change the history of medicine. William C. Campbell received the Streptomyces strain from Omura and identified the unique properties of Streptomyces ivermectilis in killing many different intestinal nematodes with extraordinary potency. Given the efficacy of ivermectin, global initiatives sponsored by WHO and NGOs have the goal now to eliminating these two diseases by 2025.
The story of ivermectin has been an incredibly positive and impactful one, with worldwide recognition of its benefits to humanity over the decades of safe and widespread use. In 2019, the world changed. And today, in 2021, we're still living and dealing with the virus that locked the world down. In reality, COVID-19 may be the only reason many even know of ivermectin. The name has been mentioned and written thousands of times during the pandemic. Now you've seen the origins, use, safety, and benefit to millions around the world. The fact is, new potential uses for ivermectin had been studied before COVID-19 stopped the world in its tracks. Aside from its antiparasitic effects, studies have shown antiviral and anti-inflammatory mechanisms of action. And as drugs are commonly repurposed after research proves efficacy and safety, this was promising for many areas of use for ivermectin. Studies have shown effectiveness against influenza, Zika virus, dengue fever, malaria, tuberculosis, leukemia, HIV, and more. It's a drug whose full scope of use is only now becoming to be understood. COVID was a global health emergency, and this prompted many doctors and researchers to investigate existing and established drugs to repurpose, placing even more attention and broad worldwide research into ivermectin's potential uses. And due to its mechanism of action as an antiviral, it could be useful across future viruses and mutations. The story of ivermectin is far from over. In fact, it's only just beginning, as acceptance of this drug and all its uses begin to be understood. That singular sample of soil and the microorganism discovered within has proven to be endlessly giving.